All right, folks, this is the lesson you have been waiting for all year. This is the introduction to the fun fundamental theorem of calculus. So what's going to happen is after this lesson, you're going to start noticing references to the fundamental theorem of calculus in media and movies and memes and things like that. Things that you all just glossed over in the past because you didn't know what it meant. Now you're going to be part of the cool crowd and you're going to recognize them. Very, very cool. Okay, so there are two parts of the fundamental theorem of calculus, and today's lesson is going to go over part one, and we're going to start with the concept of total change. So for each description, what we want is to indicate what the integral from a to b of the function f of t dt represents, and we're going to include units in our answers. So the first one says, f of t represents the rate at which your stock portfolio changed in value over the month of October. So the units of f of t are going to be like, say, dollars per day, because it's the rate at which the total amount in the portfolio changed. And then dt is a small change in days. So we say that's day, and when we multiply dollars per day times days, we end up with dollars. So that is what f of t dt is in. And therefore, this integral from 1 to 31 of f of t dt represents the total change in dollar value of your portfolio over the month of October, but let's see specifically on days 1 to 31 days in October. So when we integrate this rate in dollars per day, we get just that numerator of total change of dollars, and that's this unit right here. Okay, next problem says R of t represents the rate at which a cold yam changes temperature when placed in a 350-degree Fahrenheit oven 5 minutes after the oven was turned on. That should say oven. So what does this integral from 5 to 20 of r of t dt represent the total change in? Well, r of t is a rate of change of temperature. So it's going to be degree Fahrenheit, and I would say per minute, since our units of time are in minutes. And then we multiply by the units of dt, which is minutes. So we're going to get a total change in degrees Fahrenheit temperature of the yam on the interval 5 to 20 minutes. And that's 5 to 20 minutes after the oven was turned on. Okay, next problem. This one gets a little tricky. F of t represents the rate at which students are arriving at a ticket window, whereas h of t represents the rate at which they are processed. So we have two rates here, rate in, rate out, rate of arrival versus rate of processing. So the integral from 1 to 5 of f of t dt represents a total change in something. Well, f of t is the rate at which students are arriving. So that will be, say, students per unit of time. Maybe it's minute. dt is going to be the unit of time, so say minutes. So f of t dt is going to give us total number of students. So this is going to be, since this is the rate of arrival, it's going to be the total number of students arriving that arrive on the interval from 1 to 5 minutes. That's a total number of students that arrived on the given time interval. Well, h of t represents the rate of processing, still going to be in students per minute. dt is still going to be in minutes, so it's still going to be a total number of students. So in this case, we're going to have total number of students processed. Basically, the total number of students who had tickets sold to them. Total number of students processed on the interval from 1 to 5 minutes. So we integrated f of t and we got the total number of students who arrived. we integrated h of t and we got the total number of students who were processed and therefore left. C is f of t minus h of t. There are no integral signs here. So what we have here is a rate in minus a rate out. So what this is going to be is a net rate at which students are arriving. So net rate of arrival, if it's a positive rate, it'll be arrival. If it's a negative rate, it'll be, net processed, but it's a net rate of arrival of students in, the units are going to be students per, and I've decided to use minutes here, so we're going to have students per minute. We could have used any unit of time since they didn't tell us what the unit of time was. So now if we integrate f of t minus h of t, we are basically taking this integral minus this integral. So we have the total number of students who arrived minus the total number of students who were processed. So this is the total change in the number of students in line. And again, it's on the interval from 1 to 5 minutes. Okay, so if velocity, v of t represents your velocity, where the positive direction to the right, velocity is the rate at which position is changing. And then the integral of v of t dt from 10 to 40 would be the total change in position on the interval 10 to 40, and it was going to be some units of time there, seconds, minutes, hours, who knows. And we're going to finish up here with, this has a special name in math called displacement. Total change in position is called displacement. And a of t, of course, is the rate at which velocity is changing. So if we integrated a of t, say we had a of t integrated on the interval, same interval from 10 to 40, that is going to give us the total change in velocity on that given time period.